Let me just share my screen. Excellent. So I thought it'd be good to take some time, as Matt Jaffe keeps reminding me, to put the product back into product-led growth. So we're going to talk about some software we built. So first of all, I just wanted to talk a little bit about some stuff that Travis has recently done. There was a pull request done a couple of weeks ago called multi-tuple insert, and you'll see why this is important in a sec. So I'm just going to demo some stuff. I've got an insert test table which is not found. That's good. So I'm going to create a table with 3 columns, or 4 columns in this case, and then I'm going to insert a single row. So that's fine. Like, we've seen that before. Nothing surprising there. But this is the bit that Travis did. You can insert multiple rows at once. So here it is inserting, I don't want to scroll too far. I'm going to run that. Here it is inserting multiple rows, and that happened 100 rows in 29 milliseconds. Bear in mind, this is first cut and not optimized yet. And so just to prove that there's actually 100 rows in there, you'll see count of rows is 100. What about 1,000 rows? Let's go run that. And that one's 57 milliseconds for 1,000 rows. And we do indeed actually have 1,000 rows in the table. So if you want to play with FeatureBase now, and all you have is the SQL interface, and you want to insert some data, and you want to sit here and just express that as in multiple tuple insert statements, you can now do this with the FeatureBase bits that are in the tip of master today. What though if you have a CSV file? So let's talk about a thing that we just got in this morning that Sarah's alluding to, called bulk insert. So this is building on code that Travis wrote. So we'll create my insert test table, and now I'm going to bulk insert into this table from a CSV. And so you'll see here I have a bulk insert statement, and I'll just run it. And that came back insert test.csv. You'll see it's actually, I don't know how many rows are in here. A lot, another 1,000 rows. So bulk insert from a CSV file with 1,000 rows in it took 52 milliseconds. How much easier, Garrett, do you think that is than using the IDK consumer today?
I don't have a measurement, but it's so much easier.
Okay. So you saw basically we inserted into insert test 2 columns, or 3 columns rather, ID, the integer and the string. So let's just break this down a little bit. So you can do a bulk insert or replace, because the semantics the same, which we talked about at Sprint Review last week. Here's what you're inserting into and the list of columns that you're inserting into. And then there's this thing called a map. And what a map is it describes how we're mapping the source data, in this case from a CSV file, into expressions that we're going to put into the target. So in this case, we're taking that map expression, and it consists of a map expression and a type. So that's the 0 is the map expression. And for CSV, it's simply the column offset in the CSV file. And it's typed because for performance, it's really useful to have it typed. Because if you go and read the 0th column from the CSV file, it happens to be a string, you want to error early, right? So that's what that map is. Here's where we're getting the data from, in this case, a file. It's in a CSV format, right? So let's just select from what we just inserted. So we actually have 4 columns in this table, and we're missing the timestamp. What am I going to do about that? So what we can do is we can actually use a thing called a transform. So you notice there's an additional bit at the end of this. So you have an into, a map, and now you have a transform. And what that lets you do is it lets you take, or it lets you refer to the rows that come back from the mapping operation as variables, and then use them in expressions. So in this particular case, what it's going to do is it's going to take 0, 1, and 2 from the map, and then going to insert into our timestamp column here with the current timestamp system variable. And so if I run that and then select from the data, you'll see that we now actually have a timestamp. But we're not done. Sorry?
I just said applause.
But we're not done. So, so I have a table here called on a plane, because we're going to put some snakes on a plane. So I found I went looking for CSV examples, and I found some on this website. And this particular URL points to a CSV that it's called Shoots. The game is called Shoots and Ladders here in the US, but for those of us in the rest of the English speaking world, we know as Snakes and Ladders. And so this is just some data about games of snakes and ladders and how long the average game takes, right? So here, our data is a CSV file, but it's in a URL, and you'll see we have this input URL. So if I run that, I get an error. What's going on? And you'll notice actually, if you go to this website, and because I'm not sharing that browser, I'll just copy the first few lines of text that we see from that data, and just paste them in here so you can see. You'll notice that we actually have in that CSV file a header row. So that's where our typed map comes in handy. So what do? Well, we just add this little option down the bottom, header row. So let's try that again. And what that does is it now ignores the header row that comes in from the CSV. Right. So now if we go and have a look at our snakes on a plane, we notice that we have a bajillion rows, probably 1,000 or 10,000 rows. And you'll notice that that came from 10,000 rows from a CSV at the end of a URL. So what if we don't have a file or a URL and we just have a chunk of text? So let's create another table. And this variant here, you'll notice there's a couple of differences. We have a new input type called stream. And basically, this thing that you see here with X quote is a multi-line string literal or a blob. And so what bulk insert will do, or what the SQL language layer will do, is read from this as though it was a file. So if I run this, you'll notice that it does the insert, and if I select from that table, we get some rows. So that's sort of cool. What if I have JSON data? So we also support ND-JSON. So same deal, I've got a blob and I've got some ND-JSON data in here. And you'll notice that for the map, for this particular source data type, these are JSON path expressions. So you can run this and it will read out of the blob, go query the JSON that's in that line for that expression, make sure it's an actually the right type, and then do the insert into the final query. And just to be sure that everything's working, yes, I'm getting data. And you'll notice here's an example that I just did at the end. There's actually a unit test for this, but I created a table called all types. And here we have basically a JSON, ND-JSON line. There's only one row. And if I do the bulk insert from that and the select, you'll notice that here all the data has been inserted. And that is bulk insert. And there's been, I'd like to just thank, Travis was the one that did the initial work on multi-tuple insert. This code wouldn't have been possible without the work that Travis did. And I want to thank Matt Jaffe too for contributing to the syntax for this. There's a reason that this stuff is really, really important. Sarah talked a lot about adoptability. And one of the things that you've probably heard me say, like around product strategy, is make it easy to get data in, make it easy to get data out. And then there's a whole bunch of stuff that we have to do in the middle, which we're not going to talk about today. But this is the make it easy to get the data in part. And I know, Jaffe, you've got opinions on how this relates to our future around DAX. Did you just want to talk about like how this changes things for like future cloud efforts?
Yeah, so I mean, this is huge for a lot of reasons, right? Like we have been struggling with ingest for the entirety of our life as 7 years plus. And initially it was all the struggles were around performance, right? Like we just needed it to be faster at any cost, especially for keyed data. And so we spent a lot of time on the IDK, and before that the PDK and all the batch logic. That's been rewritten so many times. And now it's actually pretty performant. But it was still, up until recently, it was still, you had to run a separate tool to use all that stuff, for good reason. Like offloading all that processing is really helpful for the cluster. But what Travis did was basically baked all that, the important parts of that logic that make it fast, right into the query, parsing, planning, and execution layer, so that we can use it directly from that layer, which just makes it so easy for people to get data in. Like it seems so stupid, right? Like, how do I all right, so I've got a prompt at your database. How do I get data in? You put stuff into the prompt, right? Like, but that wasn't true before, like a couple of weeks ago. And now it is. And that, for just like the smoothness of the journey of like getting started using it, and then the fact that it's actually pretty performant and you can continue using this is just amazing. What I really love though is that we've now gone from being like lagging the industry in terms of ease of use of ingest to potentially leading it with this transform stuff that we can do in here. Like, I mean, Garrett can tell you better than I can. Like, everybody wants to do some funny little thing with their data on the way in, and it's often just something small. But if you have to take all your data and like transform it and shove it into a new Kafka topic, like that's a big ask. Versus the tool, you can just like add just a tiny little bit of syntax and the tool can make those transformations for you. And that is the power of having a full language layer on top of your database, right? Like it's not just SQL, like Pat is defining new SQL syntax to make all these things possible. And when you have access to a whole language and a whole compiler, you could do that. You can do whatever you want. You can get yourself into a lot of trouble too. We'll have to be careful, but this is like really fantastic. And what it means for cloud, I am going to get to the point, is that now that we have this like single pane of glass interface to the product, we can do whatever we want behind it. We don't have to run all this stuff on FeatureBase nodes. Like as this comes in, it's going to come into the querier service, and we'll be able to split off ingest, run that on, you know, a separate set of resources in the background, offload it from you know, the query nodes. We can basically do whatever we want behind it. Having this language layer in between as the intermediary is so powerful. It's an amazing abstraction, and that's why SQL, you know, has dominated for the past 40 years or whatever. And so, yeah, I'm pretty pumped.